Bismillahirrahmanirrahim. Dear students, we will discuss chapter number 4 of your book, which is named as Measure of Dispersion. In chapter 3, we are studied chapter of measures of central tendency. In measure of central tendency, we will discuss those averages which are located at the center of the distribution. In the center of the distribution are data. These are values located at the center of the values. While in measure of dispersion, we will study about the values which are scatter. Scatter are spread of values from center of the distribution. It's mean measure of central tendency and measure of dispersions are opposite of each other. The measure of central tendency does not tell us anything about the spread of values in a data set because any two sets with a vast difference in magnitude of their variability may have the same central tendency. Look at this example. If we have a data 1 which is 8, 7, 5, 8, 6, while this has the mean x1 bar 6.8. Another data set which is suppose it is second data set which has the values 1, 4, 7, 10 and 12. It also has the mean 6.8. These two data sets have the same mean 6.8, but they are differ in their variations from the central value. Look at here. So there is the more variation in data set 2 as compared to in data set 1. This illustrates the fact that the measure of central tendency is not sufficient. So we have another choice which is measure of dispersion, which is used to measure the scatter or spread of values from the central or some common values. For example, we have a two set of data which has the common point is here 51. The two set of data, one is year 2000, this is narrow and near to the central value. From the year of data 2015, this is more wide and spread from the central value. So we have to compare the two set of data, which one is better. The year 2000 is better because it is not much spread the common value or the middle value. So measure of dispersion is used to compare the two set of data and from their variation. The measure of dispersion, the dispersion is defined as the scatter or spread of values from one another or from some common values. And our dispersion of the variation may be defined statistic signifying the extent of scatteredness of items around the measure of central tendency. Why we use the measure of dispersion? Because we want to determine the reliability of an average or facilitate the use of other statistical measures. Not only we study the measure of central tendency, we have other statistical measures like the measure of dispersion, which is best to facilitate the user to use different measures, statistical measures, and serve as the basis for the control of variability and to compare the variability of two or more series. So that's why we are using the measure of dispersion. And what are the ideal characteristics for the measure of dispersion? It should be rigidly defined. Okay, and it should be easy to understand and calculate, and must be based on all observations like central tendency. Measure of central tendency is also based on all observation except mode, and this central measures of dispersion should be based on all observation. This is for ideal measure of dispersions, and it must be easily subject for further mathematical operations. Okay, and it should not be unduly affected by extreme values and must be least affected by the sampling fluctuation. There are the methods of compute the amount of dispersion present in any data are called measure of dispersion or measure of variations. There are two types of measure of dispersion. One is known as absolute measure of dispersion. The second one is known as relative measure of dispersion. The absolute measure of dispersion is its first type. The absolute measure of dispersion gives an idea about the amount of dispersion, means the spread in a set of observation. These quantities measure the dispersion in the same units. For example, if you are measuring some quantities in kilometer, liter or meter, this will be measures in the same quantities and as the units of original data. If you calculate something in kilometer or liter or meter, the same units will be calculated in measure of dispersion. Absolute measures cannot be used to compare the variation of two or more series data. The absolute measures cannot be used. While in relative measure of the relative measure of dispersion are the sort of ratio, and this ratio are called coefficients. Each absolute measure of dispersion can be converted into relative measures. When first you will measure the absolute measure of dispersion from the original data, then this absolute measure of dispersion can be converted into relative measures, because this relative measure is the ratio or coefficient of the absolute measures, and it can also be used for the comparing of two or more data set. I will also show a table for the difference between the relative measures and absolute measure of dispersion. This is the difference between the absolute measures and relative measures. As I told you before, that it has the variable unit and it has no unit. It is the free of unit, it's a pure number, and it is expressed in terms, it is not expressed in terms of percentage. It is expressed in terms of percentage because it is a ratio or in the form of coefficient. When you will calculate it, then it comes in the terms of percentage, and this is be calculated from the original data, and it is not, it is calculated from absolute measures. This measures is calculated from absolute measures, while this is calculated from the original data. This has no ratio, it has use of ratio, and this measures cannot be used to compare the variation of two or more series, and this is compare the variation of two or more series. There is no change in variation and with the absolute measures, and there is a change in variable with the there is the classification of absolute measures. The absolute measures is classified in 5 types. One is known as range, the other is known as mean deviation, 1, 2, 3 is quartile deviation, the fourth one is standard deviation, and the fifth one is variance. This is fifth one because standard deviation and variance are the same things. When you take the square of standard deviation, it becomes variance, and when you take the square root of the variance, it becomes standard deviation. While the relative measures also have 5 types. One is the just like that is range. It is the coefficient of range, coefficient of quartile deviation. Quartile deviation in absolute measure, it is only quartile deviation. Here is the coefficient of quartile deviation. In mean deviation, here is the coefficient of mean deviation. There is the mean of variation or mean of coefficient of standard deviation. These are the root and square root of each other. So we can say if we study the coefficient of variation, we automatically study the coefficient of standard deviation, because when we taking the square root of variance, it becomes standard deviation, and if we taking the square root of standard deviation, it becomes the variance. And the first type of absolute measure of dispersion is range. This is the first type. And when we have to calculate relative measure of dispersion, we say it coefficient of range. Simply, absolute measure range is the difference between the maximum and minimum observation in a data set. In this data set is the R is the difference between the maximum value and minus minimum value. Or you can say the XM is the largest observation, and X, sometimes we write here XM minus X naught, and X naught is the smallest observation in a data set. This for ungrouped data. When you discuss in group data, it becomes the range upper class boundary minus highest value of highest class minus lower class boundary of lowest class. Yeah, in other words, you can say the range is equal to class mark of highest class minus the class mark of the lowest class. And for coefficient of range, this is the relative measure. The formula: range is an absolute measure of dispersion. Its relative measure is called the coefficient of range or coefficient of dispersion, and it is defined as coefficient of dispersion range, coefficient of range. This is equal to xm minus x naught divided by xm plus x naught. This is become in the form of ratio. For example, you have this data set and find the range. The maximum value is 20 minus 50 minus 5, it becomes 15. 15 is the range of this distribution. When you have to find the uh, coefficient of range, then you will 20 minus 5 divided by 20 plus 5, 15 divided by 25. This is the coefficient, comes in the form of ratio. It is the coefficient of range. Now, what are the merits and demerits of range? It is very simple and it is quick answer. But this quick answer has the disadvantage because it gives us the rough answer. Why? because it is not based on all observation, it is based on just maximum and minimum values, the difference between these, and changes from one sample to, it is changed from one sample to the next when next population goes, cannot be calculated in open end frequency distribution and affected by sample fluctuation. These are its disadvantages. So from this merits and demerits, we can say that range is not an ideal measure of dispersion because it is not based on all observation and it is affected by sample fluctuations. It is different from the its merits, demerits is differ from the better quality of ideal, in other sense say कि ideal quality of uh, measure of dispersion. Here you can see another chart. This is measure of dispersion. In measure of dispersion, we have two types of measure of dispersion. One is called absolute measures, the other is called relative measures. We discuss both, and in absolute measures, this is range and this is the coefficient of range. This is quartile deviation, and in relative measure, it is coefficient of quartile deviation. There is standard deviation, here is the coefficient of uh, standard deviation. This is the this one. Standard deviation, the coefficient of variation, coefficient of quartile deviation, here's the coefficient of quartile deviation, mean deviation, here's the coefficient of mean variation, yeah, mean deviation, sorry.